Hello everybody, welcome into another lesson. So today we are going to start talking about inverse trigonometric functions. So, of course, when we've dealt with regular trigonometric functions, you would evaluate the sine, cosine, tangent, cotangent, secant, or cosecant of a particular angle. When we deal with inverse trig functions, we're really working backwards. So let's look at first y equals sine of x. And you notice if you go from negative pi over 2 to pi over 2, you have your full range of values from negative 1 to 1. So this is why we taught graphing of the trig functions before getting into inverse trig functions. We know from negative pi over 2 to pi over 2, you have your full set of the range. So if we restrict the domain from negative pi over 2 to positive pi over 2, you'll get the full range. Now the idea, of course, with an inverse function is that your domain and your range switch places. So the domain of the inverse sine function, so this can be written as y equals sine inverse of x, or y equals arc sine of x. They both mean the same thing. Your domain would be negative 1 to 1. Your range would be from negative pi over 2 to pi over 2. So the idea of an inverse trig function is to figure out what angle is giving you a sine of that value, or a cosine of that value, or a tangent of that value. So that's the idea of these. So for the inverse sine, your domain is negative 1 to 1. Your range is negative pi over 2 to pi over 2. And today we're not going to graph the inverse trig functions. That'll be in a future lesson. But I just wanted to graphically show you what we're really looking at here. That way you can make sense of it. All right. Now let's move on to dealing with the cosine. Alright, so of course we know about the graph of y equals the cosine of x. Well, at the cosine of 0, you have 1. Cosine of pi over 2, you have 0. And then at cosine of pi, you have negative 1. So if I go fully into, if I go from 0 to pi, I take on the full range, right? My range of the cosine function is negative 1 to 1. If we restrict the domain from 0 to pi, we have the full range of the cosine function. So now it's time to talk about the cosine inverse function. So y would equal the cosine inverse of x, or the arc cosine of x. So your domain is still going to be from negative 1 to 1, but this time your range is going to be from 0 to pi, since your range and your domain switch places between a regular function and an inverse function. And the idea of the cosine inverse is to figure out what angle is giving us a cosine of a certain value. And then, of course, we need to talk about the tangent inverse function. So let's look at that real quick here. Alright, so let's talk about, let's first start with the tangent function, your normal tangent function. So let's look at y equals the tangent of x. Well, we know we have asymptotes at negative pi over 2 and positive pi over 2, don't we? So why don't we go ahead and make those real quick? Let's go ahead and make said asymptotes. In fact, I'm also, for good measure, I'm going to include pi over 4 in this on the x-axis. So let's put in pi over 4, or I should say negative pi over 4, and then positive pi over 4. There we go. So I got the negative pi over 4 and positive pi over 4. Let's graph this. So at negative pi over 4, our tangent is negative 1. At 0, the tangent's 0. At positive pi over 4, the tangent is 1. So now we can graph this. And of course, we can go past that to negative infinity to the left and positive infinity to the right. Well, what do we notice about the range for the tangent function? It's going to be, of course, all real numbers. It's from negative infinity to infinity, right? That's our range. And it occurs in periods. It'll continue to oscillate like this infinitely. But if we restrict the domain from negative pi over 2 non-inclusive to positive pi over 2 non-inclusive, we can capture the full value of that range. So now let's flip sides. Let's talk about y equals the tangent inverse of x, the inverse tangent of x, or y equals the arc tangent of x. Both of those mean the same thing. Some textbooks use one or the other, or a combination of both. They both mean the same thing. Again, in an inverse function, your domain and range switch places. So the domain of the arctangent function is going to be negative infinity to infinity. And then your range would be from negative pi over 2 non-inclusive to pi over 2 inclusive, or non-inclusive rather, excuse me. So, and you'll see when we go to graph these in a few lessons that the negative pi over 2 and positive pi over 2 are going to act as horizontal asymptotes when we go to graph. So this is really where the whole notion of the tangent, the inverse functions come from, and restricting the domains and getting your ranges. So I just wanted to graphically show you what we're really dealing with here. Now let's get into some examples, and if you'll just give me a minute, I'm going to take away the magnetic panels here for the graph, because that's all I really had for the graph today. So just give me a minute. I'm going to lift these off. Yeah, they come in magnets. That's a side you don't often get to see, where I'm setting up and putting these magnets up. Pretty cool, isn't it? I have magnets for this. If I could get the dang things off the board. There we go. Alright, perfect. So when we go to solve these, first thing I'm going to recommend for today's lesson, set yourself up some triangles. So let's set ourselves up let's do a 30, 60, 90 triangle. So here's a 30, 60, 90 triangle. We know the side opposite the 30 has length 1, side opposite 60 has length square root of 3, and then the hypotenuse has length 2. Let's also set ourselves up a 45, 45, 90 triangle. So let's do that. Here's going to be a 45, 45, 90 triangle, because these are really going to come into play Both sides opposite the 45-degree angles have length 1. Your hypotenuse has length of square root of 2. Okay. So you may be asked something like, find the sine inverse of the square root of 2 over 2. So find the sine inverse of the square root of 2 over 2. We're going to do the answer in both degrees and radians. So this is asking what angle gives you a sine of the square root of 2 over 2. Well, that's going to be 45, right? If we want to do this in degree measure, it's going to be 45 degrees, or in radians, that would be pi over 4. So the answer to this would be 45 degrees or pi over 4. This is why you want to set up your triangles. It's going to help you a lot. Okay. What about this time we're going to have the cosine inverse of 1/2. So we're going to find the cosine inverse of 1/2. What has a cosine of 1/2? Definitely 60, right? So in degrees, that's going to be 60 degrees. In radians, that would be pi over 3. So that is the answer in both degrees and radians that you would get, 60 degrees and pi over 3. So again, this is asking you what angle gives you a cosine of positive 1/2. It's a very backwards way of thinking. But when we get into pre-calc, and especially in Calculus 2, inverse trig functions are dealt with very heavily in those courses. All right. Now, what if we were to be asked to find the tangent inverse of 1? In other words, what angle would give you a tangent of 1? That's what the tangent inverse of 1 is. That's going to be 45 degrees, right? So in degrees, it would be 45 degrees, or in radians, it's going to be pi over 4. So that's the angle that would give you a tangent of 1. All right, now we're going to take the inverse sine of 0. So what angle would give you a sine of 0? Now keep in mind that your range of the sine inverse function is going to be from negative pi over 2 to pi over 2. That means 0 degrees definitely falls into that, right? It turns out that 0 degrees gives us a sine of 0, and that'd also be 0 radians. So 0 degrees or 0 radians, both of those would give you a sine of 0. All right, now what is going to give you a cosine inverse of negative 1? So what gives you a cosine of negative 1? Now remember, your range of the cosine inverse function is from 0 to pi. Well, the cosine of pi is negative 1, right? So your answer in degrees is going to be 180 degrees or pi radians. Those would be your answers. 180 degrees or pi radians would give you a cosine of negative 1. That's what the cosine inverse of negative 1 is asking. All right, now on the other hand, what about a sine inverse of negative 1? So what angle would give you a sine of negative 1? Now keep in mind the range of your sine inverse function is from negative pi over 2 to positive pi over 2. Well, the sine of negative pi over 2 is definitely negative 1, right? So that would mean you would have negative 90 degrees, or in radians, that would be negative pi over 2. So negative 90 degrees or negative pi over 2 would give you a sine of negative 1. All right, let's see. Tangent inverse of negative of the square root of 3 over 3. So they spiced it up just a tad. Tangent inverse of negative of the square root of 3 over 3. Well, the range of the tangent function, again, is from negative pi over 2 to pi over 2, both of those non-inclusive. Which means if we have a negative tangent inverse, it's going to be in the fourth quadrant, right? Well, that would definitely end up being negative 30 degrees, right? To find that tangent, it would be negative 30 degrees, or you could also say negative pi over 6. That would be the answer in both degrees and radians. Negative 30 degrees or negative pi over 6 would yield a tangent of negative square root of 3 over 3. All right, and then last basic one, we have the cosine inverse of negative of the square root of 3 over 2. So what angle would give you a cosine of negative square root of 3 over 2? Well, we remember the range of the cosine function is from 0 to pi. And if you have a negative cosine, that means it's going to be in the second quadrant. So the only angle in the second quadrant that would do that is going to be, that would be 150 degrees, right? So you would get 150 degrees or 5 pi over 6 radians. So in degrees, you would get 150 degrees. In radians, you would get 5 pi over 6 would yield that cosine inverse of the negative square root of 3 over 2. All right. Let's mix this up a little bit here. Now, let's say you have something in general like the tangent inverse of 3.9. So these next several problems are going to be based on the domain rather than the range. Well, what is the domain of the tangent inverse function? It's from negative infinity to infinity, right? Let me grab my calculator, which is my phone. Alright, so let's grab the calculator here, which is on my phone. So we're going to find, again, in both degrees and radians. Make sure your calculator is set for the appropriate mode. So let's find the tangent inverse of 3.9 in degrees. You're going to get, we're going to round to 3 decimal places. You would get approximately 75.619 degrees. There's your degrees answer. Now we need a radians answer. Let's put that into radians. You would get 1.320 radians. So in radians, it would be 1.320. In degrees, it would be 75.619 degrees, would give you an inverse tangent of 3.9. All right, what about a cosine inverse of positive 0.24? A cosine inverse of positive 0.24. Well, what is the domain of the inverse cosine function? It's from negative 1 to positive 1, right? So we're well within our domain. We can definitely solve this. So let's go ahead and first find the answer in degrees. That would give you 76, approximately 76.113 degrees for that cosine inverse of 0.24. Now let's take the same answer into radians. That'd be about 1.328 radians. So in degrees, you'll get an answer of approximately 76.113 degrees. In radians, you get an answer of approximately 1.328. All right, now what about a sine inverse of 0.75? So first we'll find the answer in degrees. We'll ask ourselves, what is the domain of the inverse sine function? It's from -1 to +1. So again, we're well within our domain. So put this into degrees. Sine inverse of 0.75, that's approximately equal to 48.590 degrees. Now let's figure this out for radians. You get approximately 0.848 radians. So in radians, you would get approximately 0.848. Let's do one more of each. Let's say I take the sine inverse, this time, of -0.4. I'm going to take this inverse sine of -0.4. Well, what is the domain of the sine inverse? It's -1 to 1, right? So we're well within our domain. Now let's get a degree answer first. To 3 decimal places, you get approximately -23.578 degrees. So in degrees, you get approximately -23.578 degrees. Now let's find this in radians. You get approximately -0.412 radians. So there's your degrees, there's your radians. All right. Now let's see here. Good one. Cosine inverse of -0.6. Once again, what is going to be the domain of my inverse cosine function? -1 to 1, right? So let's go ahead and first find the answer in degrees. You get approximately 126.870. If you're rounding to 3 decimal places, your degree measure is approximately 126.870 degrees, which makes sense because your range is from 0 degrees to 180 degrees. So that actually checks out. Now, let's convert this into radians this time. So into radian form, take the cosine inverse of -0.6. You get approximately 2.214 radians. So your radians would be approximately 2.214 radians. And just one more I want to do. And then we'll solve a few triangles. We're definitely going to do a tangent inverse for sure. let's do the tangent inverse of negative 12. So let's take that, the inverse tangent of negative 12. Well, we know the domain of the inverse tangent function's all real numbers. So, but the range is from negative pi over 2 to positive pi over 2 non-inclusive, or negative 90 to positive 90 non-inclusive. So let's take that here. You would get approximately negative 85.236 degrees. So for your degrees, you'll get approximately negative 85.236 degrees. Now let's find this in radians. You would get approximately negative 1.488 radians for your radian measure. So that is your degrees in radians. So that's how you evaluate your inverse trig functions, and your calculator should be set up for the domain and the range of your inverse trig functions. Now we're going to use this to solve a few triangles. It's going to be pretty easy. So let's say, what have we got here? Alright, so we want to solve for theta, right? So we need to find that angle. Well, we have 2 over 4. We have opposite and an adjacent. So that means we have the tangent ratio. We know the tangent of theta would equal 2 over 4, which happens to mean it's going to, of course, be 1/2. So to find theta, we'll take the tangent inverse of 1/2. Now we're going to find a degree and a radian measure to approximately 3 decimal places. So theta would be approximately equal to, since the tangent's positive, we know it'll be in the first quadrant. So let's do degrees. You would get approximately 26.565 degrees. And then we can also put this into radians. You would get approximately 0.464 radians. So the answer for the angle in degrees is approximately 26.565 degrees, or about 0.464 radians. And there's plenty more where this came from. All right, what's next? Alright, so we're going to find angle theta again. We have an adjacent leg and a hypotenuse. What ratio is adjacent over hypotenuse? Definitely the cosine, right? So if we take the cosine of theta, we can set that equal to 2/3. Which means theta is going to then equal the cosine inverse of 2/3. So now we can go on ahead and find approximations in both degrees and radians. So let's go ahead and do so. So for degrees, you'll get approximately 48.190. And then let's figure out our radians. radians, you would get approximately 0.841. So there we have both the degree and the radian measure approximation for angle theta right here. Approximately 48.190 degrees, or approximately 0.841 radians. Alright, so here's another right triangle where we're going to solve for theta. This time we have an opposite leg and a hypotenuse. The relationship between opposite and hypotenuse is definitely the sine, right? So that means the sine of theta is going to equal 4/7, which means theta would be exactly equal to the inverse sine of 4/7. And now we can find both a degree and a radian approximation for theta. So in degrees, you'll get approximately 34.850 degrees. Now we can deal with the radians. You get approximately 0.608 radians. So there is going to be both your degree and your radian measure. Approximately 34.850 degrees, approximately 0.608 radians. And I got two more. Opposite over. All right. So we have another right triangle here with angle theta. Again, we have an opposite leg over the hypotenuse, which is going to be the sine ratio. So that means the sine of theta is going to equal 6/10, or reduced would simply be 3/5. So that means theta is going to equal the sine inverse of 3/5. And now we can go ahead and find ourselves an angle approximation in both degrees and radians. Alright, so in degrees you get approximately 36.870 degrees. Now we need to get radians. In radians, it's approximately 0.644 for the radians. So angle theta in degrees is approximately equal to 36.870 degrees. In radians, it's approximately equal to 0.644. And I have one more, just one more. All right, last one. So we have angle theta, where you have an opposite leg of 3 and an adjacent leg of 9. Well, opposite over adjacent, that's the tangent ratio. So this means the tangent of theta is going to equal 3/9, or you could reduce this to 1/3. It would give you the same result. So that means theta is going to then equal the tangent inverse, or inverse tangent, however you want to say it, of 1/3. Now we can go ahead and find ourselves a decimal approximation in both degrees and radians. So let's do that. Whoops, let's do this in degrees first. Alright, so in degrees you get approximately 18.435. So that's approximately 18.435 degrees. Now let's find this in radians. That's approximately 0.322 in radians. So angle theta for degrees has an approximate measure of 18.435 degrees, or in radians, approximately 0.322 radians. So that is an introduction to inverse trig functions and how we use it, how we apply it to solve for angles. The next lesson we're going to get into compositions of trig functions. So I hope everyone has a great night. Take care.